All right, so it's already been a long few days for me, and so I've decided to take some shortcuts and cheat some when I can. As I flip back through some slides, I don't remember what year this was, but maybe it was last fall. I had a change of base theorem slide made up, so I'm just going to talk over the top of what I've already written, and hopefully keep this kind of short if I can keep my mouth focused and pointed in the right direction. So when we're using our calculators, when we're dealing with logarithms, our calculator understands two bases. Okay? It understands a log, that's one button, which it takes every time to be log base 10, and it has an ln button, not written in cursive on your calculator, but that's not an I, it's an L, okay, which means log base e. E being the natural base. Okay, those are the two buttons my calculator understands. Some of the more sophisticated calculators today honestly can do other bases, but we're going to assume that we have some older technology and these are the only two buttons we see. When that's the case, if I have something on my calculator, like maybe I want to find log base 2 of something, or log base 8 of something, or log base square root of 7 of some number. I can do that in, these guys here are b's, letter lowercase b. Okay, the same b we've talked about before up to this point where b is a positive number. B can't be equal to 1, and I get to choose it. It can be any b that I want. So I could change from base 2 to base 12. I could change from base 7 to base 0.7 if I wanted to. However, if my goal is to get a numerical estimate, an approximation for that, okay, I can scroll down just a little bit at a time. I'm going to either pick base 10, common log, or I'm going to pick base e, natural log. My calculator doesn't understand log base 3 of 2, but it does understand log of 2 and log of 3, where when I just say log, that means common log. It understands natural log of 2. It understands natural log of 3. So where this square is up here, this box on the page, I get to fill that in with any number that I want to. Okay, so if I wanted to, I could say log base 9 of 2 over log base 9 of 3. That's a completely, totally true statement. However, again, not helpful to me in most situations. Not helpful to my calculator that only understands 10 and e. So as long as you use the same base top and bottom, you should get 0.6309 either way. So try this for yourself. Find me log base 7 of 12. On the top goes log of 12. On the bottom goes log of 7. And when I say log, it can either be common log or it can be natural log. And depending on which one you plug in, you are still going to get the same answer. It doesn't really depend on it. Okay, as long as you use the same base top and bottom. When you're doing a homework for me and uploading those into Canvas, when you're taking a test or a quiz on this, I need to see that step, the one with the blue arrow. If you write log base 7 of 12 equals 1.2770, yes, numerically that's correct, but I need to know that you know that change of base theorem. Okay, because even if your calculator is one of the smarter ones, if I change those 7s and 12s to x plus 1s and x minus 3s, I still need to know that you know the relationship between those two expressions. Okay, because there are situations in classes beyond where we need to use this change of base relationship, this ratio on the right. So show me your step if you want full credit. Your book has lots more examples of these. I say lots, they have some. And come see me if you need more than what's here.